Good afternoon. Today we will be discussing about corrosion protection coating for underground steel pipeline. This information about me. Now, what is important about corrosion protection? The corrosion protection coating is being used for maybe last 70, 80 years, and there have been a lots of oil and gas pipelines which are still functioning, and the industry has been working on this. But there are changes now. There are new developments. The improved technologies are coming into place. The method of applications have improved. So we will be discussing on the important part, the new changes and new positive improvements in the coating technology. So as part of this discussion, we will talk about what are the different types of coating technology, what are the application processes, what controls can be made and improved, and in what environment the pipelines have to be constructed and operated. And we will also discuss that in case if there is error in application or there's a dilution of the discipline, then how it impacts the long-term performance of the coating and the long-term performance of the service of the pipeline. So all of us know that fusion bond epoxy coating is the important part of corrosion protection technology for underground pipelines. And this technology was invented about 60 years ago. And since then, it has been in use. So we will be discussing that what are the quality assurance part of application process. And the company which invented the FB has also played a good role in terms of developing the good quality assurance system for the application process. And it also worked with regulatory industries like Canadian Standard Association, Indian International Standards Organization to have a comprehensive system of testing, qualification, sampling plan, method of evaluations, and the decision making process in terms of acceptance criteria. So we'll be talking about that. The very important part of this coding is that we need to know that how this application process impacts the long-term service life under varieties of service conditions. Other than line pipe coating, there are components of pipe construction which is field joint coating, though we'll be touching on that also. Now, what is fusion bond epoxy coating? It's physically a powder which is largely based on epoxy resin, and it is created in a way that there are so many components in the physical PFB powder. One of the main raw material is a specially chosen epoxy resin in the solid form. And of course, the manufacturers know that what are the characteristics of that resin which has to be used. So it's not a general purpose resin, it's a very specifically developed for this purpose. The second most important composition is the catalyst part of it. It's again a chemical which actually reacts with the epoxy resin. The catalyst can be amine based or different kinds of materials are used as a catalyst, imidazole, etc. Then there is a curing agent. Now, why do we need two items like catalyst and curing agent? Because during the application process, there is a requirement that powder should form a gel. Okay, certain period of time, a few seconds at a certain temperature. So there is a component called catalyst, which controls the gel time of the powder. And there is another chemical which is a curing agent, which actually helps to completely cross-link the epoxy resin. So there are two components. It is adjusted as per stoichiometry. And then we have pigments to give a color to the coating. We have got some fillers and additives to give certain properties like hiding power, hardness, impact. Several other properties are associated with these additives. Flow modifiers, etc., etc. So maybe around 10, 11 or plus components are physically mixed together, extruded, goes through a series of process to finally form a ground powder. So that powder is used by the applicators. Now, in the global industry, there are some regional effects in terms of trends of what type of coating is used. So if you look at North American countries, like North US, Canada region, and some of the South American countries, they largely use single layer of fusion bond epoxy coating from last 70 years almost. And that's depicted here in the green color. That's only one layer of thick single layer AB coating is applied, and that gives a good enough properties. When we come to Europe and Middle East, there is another trend here that a three-layer polyethylene coating system is being applied. And the three-layer polyethylene coating system was introduced after AB was introduced. What was the reason of that? That fundamental thing is that pieces of pipe are coated in a factory, and then they are transported through a truck drive to the construction site. During this truck drive, the pipe have a lot of bumpy rides, which the pipes will impact each other. And during handling, the pipes are taken through the powered crane. And so there are some impacts and some damages are noticed in the case of single layer B coated pipes. So the industry came up with a very robust design of three-layer system. That means the first layer is still a thing, B, which provides a corrosion protection. Then there are other two layers. Adhesive is one which actually combines, attaches the two layers of a B and outer layer of polyethylene compound. And it's all applied through extrusion process. So as a design, this is a very good technology, very robust, and it is still being used in India and Middle East and Eastern Europe. We will be discussing in detail, are there any limitations with this technology? What are the plus points? Then the third picture you see on the right side is a new technology. It's called dual layer FBE coating. And why dual layer FBE coating is used? This technology has been introduced in last 20 years. That the first layer is still FBE and the outer layer is abrasion resistant overcoat FBE. This is also fusion bond epoxy material with this very high impact resistance, very much high in terms of hardness and in terms of weathering properties. And the beauty is that these two materials they react with each other and make a structural bond. So after the coating is applied, it becomes a unitized dual layer coating. Now, in order to apply any type of this coating material by an applicator, there has to be a directional document which provides guideline and helps the applicator to stick to the certain important point. And that is a live document for the application process. This same document is there with the applicator, with the inspection agency, with the client, and it helps like a Bible to settle any dispute or any ambiguity or provides clarification as what to do in case some deviations are noticed. So this is the good practice. And what is needed is that in this documentation, if there are any improvement in terms of how to improve the surface preparation, how much improvement is needed in terms of application speed or temperature, that should all be mentioned in this document, which is called a tender specification. So as a manufacturer or as a consultant to this industry, our team is continuously in contact with all stakeholders. We provide data, we collect data through our network. There are several third-party research organizations who are continuously working on methodology of improvement, so that updated information is available and that helps to improvise this document. Now, if we're talking of three-layer polyethylene coating, there are three most important parameters here. And why it is important? Because when these pipelines are constructed in the field, the pipeline has to be bent according to the topography or path of the line. So when it is three-layer coated, it's very difficult to find out what's happening with the AB primer layer. So there is new suggestion in the contractual spec that before we start the application process, we coat a few pipes only with single layer AB and conduct some additional test to make sure that three-layer coated pipeline will always be performing as expectation. So one of the most important parameters is flexibility test for the single layer coated pipe. And normally ISO standard is referred in most of the specification, but in this case, ISO is a very easy specification to meet, 2 degree per pipe diameter at 0 degrees Celsius. There is a need to have a more stringent specification so that the assurance part is there, that this will not have any probability to crack or fail when the pipeline is constructed. So our suggestions has been with several companies, and some of them have adopted to make it as 3 degree per pipe diameter requirement to be tested at minus 30 degrees Celsius. And this is coming from a CSA specification. So there is already a regulatory spec available, and many companies have adopted it. Number two parameter is resistance to cathodic disbondment. This is actually a measure of simulation that how this corrosion protection coating will protect the pipe in the field condition. So there are again several specifications like CSA and ISO, and most commonly in ISO it's written as 24-hour CD test at 65 degrees Celsius should be less than 7 mmR. Our recommendation is to make it a little bit more tight and make it as less than 6.5 mmR, and it has been implemented in some companies. The third parameter is hot water soak adhesion. It is actually wet adhesion test, because when the pipeline is constructed and running, the soil could be wet. In many cases, the soil have got a high water table and they're very wet. So what is the continued adhesion level of the coating under these conditions? So there is a third test parameter which was created by this regulatory specification to actually simulate that service condition. So we generally test 24-hour hot water soaking adhesion test at 65 degrees Celsius as per ISO. And what we have suggested to improve it, and many companies have taken the reference from CSA, and now the new requirement is rating 1 as per CSA, and the hot water soak adhesion test to be done at 75 degrees Celsius. This is the immersion test. So if they take care of these parameters, all others will fall in place. Now the question is, how do we ensure, how do we adopt that every piece of the pipe which is coated follows this? Because typically after procedure qualification test, it can take several weeks or several months to complete the project. And applicators will run this coating process continuously for 3 shifts. So in order to ensure that every pipe which is coated follows this, there are some guidelines. First of all, select the FB powder which has got a wider window, that it can take care of the fluctuations in the conveyor speed or fluctuations in the pipe temperature. If the FB powder is not having a wide window, and for any reason if the temperature fluctuates, then the adhesion levels may vary. So that's very important. Second is The inspections for incoming pipe is also important, that incoming pipe does not have any effect before the application process. A salt contamination has to be done on a blast clean pipe, and it should be ensured that it is within the limit. Otherwise, there is a recommendation to use a very high pressure water wash. Also, it should be cleaned by using a phosphoric acid so that all the salt gets combined with the acid, which is followed by water wash. So acid should also be removed. So that is why there's a pressure requirement that at least 2000 psi of RO water is needed. So again, because people can choose different times how much to wash. So there is a specification provides a guideline that what's the minimum dual time when we still need to be in contact with acid, and what's the time it's needed to wash the water. All right. Then there are other important recommendation is that the steel temperature should also be kept high at the time of application, because higher steel temperature will ensure a good wetting of the molten powder, and it will always give a high performance. So that is why there are companies who have now specified that a minimum of 230 degrees Celsius is needed. FB should not be applied for temperature below this requirement. Okay, let's see how the flexibility test is done. We mentioned three parameters, and one of them is flexibility. So as per Canadian standard specification procedure, the pipe, the FB or DFB coated pipe needs to be cut in something like 1 inch into 8 inches size of panel. And in the middle picture, you see a brown color panel, which is actually a piece of pipe. And before it is bent, it is kept into a freezer at minus 30 degrees Celsius for at least 1 hour so that the temperature is stabilized. And the panel is taken out, and a stopwatch is there to measure how much time it takes to bend. So there's a guideline that how quickly it has to be bent. The panel is placed in the bending machine against a mandrel, and mandrel is designed for a angle something like 3 degree per pipe diameter. And the bending is done very quickly. The details of speed and time is written in the specification. After the panel is bent, it is kept on a table or a platform with the stopwatch, and at least for the next 1 hour, 60 minutes, there is observation that it should not develop any crack or pinholes. And then there is a small low voltage tester to run onto the pen bars to check if there is a discontinuity or holiday. So that completes the flexibility test methods. Second parameter is resistance to cathodic disbondment. Again, very important parameter for coating. And in the picture, it is shown that a piece of pipe is taken in the bottom, and a plastic or glass beaker is built on it by using a sealant. There is an intentional holiday created, and holiday means there is small incision, there is a small circle is intentionally cut using a knife, and the guideline says that it should be 3 millimeter diameter. There is an electrolyte solution, which is 3% sodium chloride and water. And then there is an electrode attached through the electrolyte, typically a calomel electrode. 3.5 volt DC current is applied to the circuit, and the temperature of assembly is kept at about 65 degrees Celsius by either using an oven or using a sand bath with heater. And this test has to continue at least for 48 hours. And this is a very high accelerated condition of corrosion, which happens in the service condition. So after 48 hours, this assembly of beaker and all is removed. The panel is allowed to cool down to a room temperature, and then a knife is used to remove the coating. In case if this whole accelerated process has creeped inside the coating and it has affected the adhesion of the coating, then the coating comes off with the knife. Otherwise, it will resist. And then finally, there is a measurement done that how much increment of coating removal, and that's a measure of adhesion to for the coating. This is called resistance to cathodic bombardment. Another third parameter is adhesion of the coating material. Because it's a epoxy, it's bonds very high with the steel. It's called a structural adhesive. So there are two ways to test it. One is in the laboratory where you see the brown picture A, which is the overlap shear strength. And if we do it that way, it will show me more than 4000 psi, which is measure of structural bonding. But shear adhesion cannot be done every day. So it's panel has to be prepared, bonded, and cured. So it's like one-time qualification testing. But what is more common, which can be done every day, is a pull-off adhesion test, which you see the green color picture. The aluminum dolly bonded onto the coated surface by using a structural adhesive. After adhesive is cured, there is a equipment and the dolly is pulled. So again, the value of pulling force can be measured either in psi or in megapascal. Some equipment will measure in psi, so anything above 4000 psi is a good adhesion. Or if we measure the data in terms of megapascal, it should be at least 30 to 40 megapascal. So that's a very, very high level of adhesion for a beam. So this tender documents normally recommend that when a single layer pipe is coated, this pull-off adhesion test to be performed. Now we are moving to a dual layer system. We discussed about 3 different options. In this diagram, you see the green color material is FBE primer for corrosion protection, and the outer layer is called abrasion resistant overcoat. FBE. Both are FBE. The outer layer material actually provides a very high impact strength, high abrasion resistance. It basically protects the FBE primer during the handling and transportation. And this is very rugged system. This combined coating system resists a temperature up to 110 degrees Celsius. So pipelines which are operating at say minus 30 to 100 degrees Celsius can utilize this technology. Very fast, ease of application as compared to 3-layer. This system can be applied with a greater speed, so the pipeline project can complete on time. Easy to handle, very easy to inspect and repair the coating defects. And the total thickness required for corrosion protection in this case is only about 800 to 900 microns as compared to polyethylene, which is 3 millimeters. So this is consuming less quantity of coating material. It's more economical and with higher performance. So many companies have adopted this. Even in India, Indian Oil has adopted this. And a lot of companies in other countries are using dual layer technology. And lots of pipes or projects are done in India for export to different countries. In terms of application of dual layer, it's very simple. All of the applicators have got 2 booths. The first powder spray booth is for the primary layer, and the second booth, which is next to the first booth, is for ARO powder. So it's so easy to apply and easy to recover the recycled powder. There are so many tests, but one of the most important tests is the gouge test as per CSA. Now, what is a gouge test? The piece of coated pipe is taken into lab. About 50 kilogram weight is applied through a very hard burr, and the panel is pulled in a horizontal direction. So the hardened burr will actually inscribe into the coating. So what we did is we compared 2 panels. One is 3-layer polyethylene coated panel and a ARO layer coated panel. So we see that blue line is representative of the 3-layer polyethylene coated pipe piece, and the red line is representative of ARO coated pipe piece. Now, why we did this comparison is because in our country, especially in India, when pipeline is being constructed, typically the outdoor temperature is about 30 to 40 degrees Celsius. So if we do the gouge test, which is a simulation of backfill, like earth material which is taken out from the trenches or put back after the pipeline is put into the trench. So these have got a lot of rocks, hardened pieces of earth, which goes and impacts the pipeline. That's something like gouging the coating. So just look at these data. If we do the gouge test at minus 20 degrees Celsius, there is some difference because polyethylene actually gets cut with the gouging action, and the ARO coating does not. Very little impact. But when we do the same test at a temperature like 40 degrees Celsius, there's a more deeper cut in case of three-layer polyethylene coated pipe. That's called a very high gouge depth. We have data that it shows that almost entire thickness of polyethylene, which is about 3000 micron, gets cut at this temperature. While if we do it with ARO, a very minimum inscribed is noticed. Very minimum, maybe 10%, 15% depth. In case of three-layer polyethylene coated, we see like 75, 80% depth. So this is generally not noticed by anyone. The reality is that the pipeline is constructed with a heavy gouging action unnoticed, and those are the potential crisis situation that in long-term service performance, the portion which is suffering heavy gouge will start higher level of corrosion. So this is something now is coming into the specification that at certain frequency, the coated pipes need to be tested for gouge. And that's a responsibility of applicator, how to organize that test. So it's very important for long-term performance. The dual layer is also tested for weathering resistance by a company called Atlas, which is known for natural weathering. And they have evaluated fields for 12 months of natural weathering that even if the pipes are lying on the dump site and exposed to natural weathering, even sites like Chennai, which has received a very high UV resistance, UV light, the coating remains unaltered. It does not deteriorate. After 12 months of weathering, these panels were tested again for the original specification like adhesion and flexibility and impact, etc. The only observation was that the glossiness of the coated panels that faded out a little bit. There is a color fading effect after 12 months exposure, but there was no deterioration in performance. Now, moving a little bit after the line pipe coating, when the piece of pipe is coated in a factory, it's called line pipe. It's a standard 12 meter. But these pieces of pipe have to move to the site for construction of a longer pipeline, and then they are welded together. It's called girth weld. So the girth weld area, which is also called field joint, also need to be coated with a corrosion protection coating. And the material should exhibit the same level of corrosion protection performance which line pipe FB or DFB coating is doing. So we have, or each manufacturer has a compatible high build liquid epoxy coating, which can be applied easily in the field, and it also gives you the similar kind of performance. So here is one picture of a project in Gujarat where a high build liquid epoxy was used on field joint coating, and this is color matched. Another topic is for especially for gas pipeline, there is an internal coating which makes the surface smooth, and it helps in pumping the gas. And typically these are governed by two regulatory specification, American Petroleum Institute and ISO. Typically a very thin 100 110 micron coating thickness is applied, and the purpose of this coating is to provide a smoother surface so that there is substantial saving in the pumping of the gas. And it's like a given and mandatory for all gas pipelines. So there is one company in South America, it's called Gas Atacama. What they did is that they took two pipelines of identical diameter and wall thicknesses for the hydrocarbon gas, like natural gas pipelines. And they applied different kinds of available flow coating materials, some with a very high volume thick solid and some with normal moderate volume solid. And they did the calculation and came up with criteria that the higher volume solid product, which gives a smoother surface, and that the smoothness can be measured in terms of RZ value, gives a better advantage in saving on pumping cost. Now here are some picture where a new technology is being used in terms of flow coating. It's a solvent-free product, 100% volume solid. No solvent is used. This product gives a very smooth surface, very safe, no hazard, no fire hazard, no discomfort to applicator because there are no fumes of hydrocarbon solvent into this. The product gets applied very smoothly and the glossiness is high. The product cures very fast. Typically, available products in the market are like 50% volume solid product, which take like 5 days to cure, 7 days to cure. This product can cure within 5 to 6 hours. So the advantage for applicator is that once the pipe is coated, within 5 to 6 hours, the pipe product is cured, can be inspected, certified, and dispatched. So they don't occupy a lot of space in their yard, and they can turn it high, and they can increase the speed of production, and their output will be very high, like high productivity. They can dispatch the pipe within 6 hours, clear the space, and coat new pipes. So applicators are very happy with this, and it's not only applicator, it's also high performance because the RZ value with these kind of coating is less than 1 micron, which is very smooth. For the normal solvented product, we get like 8 to 10 microns. With solvent-free product, we are getting 0.5 microns RZ value. So it's really smooth and a lot of benefit in terms of operating the pipeline. Now, this information came from this company, Gas Atacama, and they actually published, they wrote a paper on this, that what are the benefits of using solvent-free product. Thank you so much. Open for any question. I would like to invite if there are any questions related to any section of this presentation.